Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Welcome to the Explainer. Today, we're going to cut right past the flashy marketing and the slick UIs to look at the actual anatomy of great software. We're talking about decoding the precise line between a totally frustrating, glitchy build and a completely flawless digital experience. Let's get right into it. Okay, so let's dive into this. What makes software actually good? Beyond a sleek design or a really clever logo, Earning a user's trust actually requires a very specific set of underlying mechanics. According to the official source definition, software quality is the degree to which a software product meets specified requirements and satisfies stated and implied needs. It's a high bar, right? But this is basically the soul of the software organism. It's the definitive yardstick we use for literally every development cycle. Section 1, Stated versus Implied Needs. So there is this fascinating tug-of-war happening right inside that definition we just looked at. On one hand, we've got specified requirements. Think of this as a developer's checklist. It's exactly what the box says the software does. But on the other side, we have the human element, implied needs. You don't write, "Please don't drain my battery in 10 minutes" on a formal feature request, but your brain absolutely expects it. True quality bridges that gap between the rigid paper specs and actual human behavior. Moving on to the core user experience. To really wrap our heads around this, it helps to split our perspective into two camps, the user versus the builder. Our source breaks this down into 6 vital organs, or quality factors, that keep the software organism alive. We've got functionality, reliability, usability, efficiency, maintainability, and portability. We're going to start by looking at those first 3, which are the ones you, the user, directly feel. This brings us to a super foundational question. Does the software actually do what it's supposed to do? Think about how often the answer to that is surprisingly no. This is the exact moment where user trust either begins or totally falls apart. So, the crucial point here is functionality. It's the fundamental ability of the software to perform its intended tasks. This is the absolute bare minimum, right? If you download a financial app, it really doesn't matter how beautiful the dashboard is if the balance calculation is wrong. Fail here, and the software is pretty much dead on arrival. But hey, functionality isn't quite enough on its own. The next big question we have to ask is, does it perform consistently without failure? Just imagine an app that works flawlessly on Monday, but then completely crashes on Tuesday, right when you're in the middle of presenting to a client. That brings us to reliability, consistent performance without failure. Because honestly, anyone can make a program work once in a perfectly controlled laboratory setting. But doing it 1,000 times under terrible network conditions with a dozen other apps running in the background, that kind of consistency is exactly what separates a neat little idea from a truly great professional product. Which brings us to our final user-facing hurdle. Is it easy to use? Because you could build the most rock-solid software on the entire planet, but if a user literally needs a map and a compass just to find the settings menu, well, you've got a massive problem. And that is usability, the ease with which a user can interact with the software. This neatly wraps up our front-end section. Functionality and reliability mean absolutely nothing if the user just encounters a giant wall of confusing menus and gives up. Usability is basically the translation layer between complex code and natural human intuition. Next up, under the hood, efficiency. All right, now we're shifting gears to the builder perspective, the stuff happening out of sight. Does the software use resources effectively? Now, as a user, you might not spend your day thinking about processor math, but you are definitely going to feel the consequences of it. This is all about the efficiency attribute. Our source directly highlights CPU and memory management here. Remember a few minutes ago when we talked about those implied needs? This is a prime example. You never explicitly ask the developer to optimize their CPU cycles. But when an inefficient app makes your phone run incredibly hot and drains your battery from 100% to 0 in an hour, yeah, you're experiencing a catastrophic failure of software efficiency. Let's talk about future-proofing the software. This brings us to the key of long-term survival, because here is a universal truth. Software is never truly finished. The environment around it is constantly shifting, which demands that we ask, can it be easily modified or fixed? This is maintainability, which is the ability to easily modify or fix the software. Honestly, it's the invisible hero of software engineering. When a zero-day security bug hits, or a massive new feature needs to roll out overnight, high maintainability is what lets developers push updates without breaking the entire system. Low maintainability? That means every tiny little fix triggers a catastrophic ripple effect. And finally, we have to look at the reality of modern technology. I mean, we don't just use one device anymore, right? We're on laptops, tablets, smartphones, smartwatches, the whole shebang. So our final attribute question is, can it run on different platforms? And this brilliantly illustrates portability, the capability of the software to run on different platforms. Great software isn't just trapped in a single ecosystem, it adapts. If an application requires a complete, from-scratch rewrite just to move from Windows to Mac or from iOS to Android, it severely lacks portability, bringing it all together into the complete quality picture. So here is the master blueprint. It's like a giant puzzle that requires a really delicate balance. You combine the front-end user experience, that's your functionality, reliability, and usability, with the back-end builder needs, efficiency, maintainability, and portability. If you remove even one of these pieces, the whole structure gets totally unstable. A highly usable app that constantly crashes? Failure. A perfectly reliable app that's way too confusing? Also a failure. All 6 of these absolutely must operate together to elevate plain lines of code into a seamless digital experience. So, what does this all mean for us? Well, I want to leave you with a provocative thought as we wrap up today's explainer. Think about the application you opened the most this week. How does it actually measure up to these 6 pillars? Does it respect your implied needs when it comes to efficiency? Is it genuinely reliable? Or, honestly, have you just kind of gotten used to its flaws? Take this structured framework, apply it to the software you use every single day, and I guarantee you, you will never look at an app the exact same way again. Thanks for exploring this with us. Keep analyzing, and we'll catch you next time.